Hello everyone, welcome back to LeetCode Daily Live, where I do the daily question raw and uncut. So it's actually, as you see here, my 100th streak today if I finish this. So I'm quite excited for this. And yeah, so let's look at what the question is. So it's called Count the Number of Fair Pairs, and we have a list of numbers, which is 100k. And then, okay, so each of the number could be any int. So like it is int 32 and it could be negative. Lower and upper, same thing. So that will be these parameters. So let's see what it wants. So that's what we are given. We want to return the number of fair pairs. So because we are doing pairs, it will be n squared if we do if we brute force. So we have to think of ways to optimize that. So a pair is fair. So again, the pair has to be ordered. So I has to be smaller than j. And okay. So lower. So the sum of the two numbers at I and j index has to be inside lower and upper. So the first thing I can think of straight away would be we need to sort nums, so we can use binary search to find some bounds. So for example, if nums I is 0, right, and lower is -2, upper is 2, then that means the range of numbers we can get for nums j would be -2 all the way to 2, right? So if we have a sorted list, we can just get the index of the lower and the upper bound. So and we can quickly find how many numbers are there. Yeah, the other thing is, so for here, well, I has to be smaller than j, right? So that means if we sort the numbers, we will have mixed up all the i's and j's. So we need some ways to account for when we actually sort the numbers. How are we checking? Yeah, how we gonna check the numbers we got? Maybe I'll draw it out. So let's say our original list is something is that a good example? Whatever, I'll use this. So when we look at 0, and let's say our bound has to be -2 to 2. Well, if we get the range, it will be this range here, right? So all these numbers, when we add with 0, so the number, it's going to be between this range, right? But the problem is when we are looking at the when we look at 0, we are only nums is only allowed to be the numbers after 0, right? So we actually can't use -2. But as I'm explaining this, I thought of a solution. So what I'm planning to do is we're going to use a sorted list, so from sorted containers. And the good thing about sorted list is that you can add and remove elements in log n time. So that means when you remove, so for example, the sorted list will have this, right? So we look at -2, and then, well, obviously we can check that, we can check -2, but then when we finish with -2, we can remove a -2. Yeah, and I think for sorted list you can have multiple elements that are the same, and you can remove only you have the option to only remove one of them, I think. But I could be wrong. But yeah, I think with this technology we can just easily solve the problem. So yeah. So let's get coding. So from sorted containers, import sorted list. Yeah, again, sorted list is really powerful in Python, especially you don't have order sets and order maps. Well, you don't have the normal set and maps in C++, which does the add and remove stuff in log n. Like you kind of need sorted list for those cases. So first thing is we want sorted nums. So it will be equal let's see. Yeah, so we just need sorted list and then we'll add nums into it. And then now for the numbers in our original nums, so the first thing we want to do is actually remove our current number from the list, because we also, so like let's say lower and upper is like let's go back to this example. So if we are looking at 0, if we don't remove it, well, 0 plus 0 is actually within this range, but that's not allowed, right? So we want to like remove one of the zeros first. So we do that, and then I think we want to get the range for the second number. Which I think like we can just do left and right. I'll separate them. So we want to do bisect, right? So sorted nums bisect. I think we want bisect left for the left bound, and we want bisect right for the right bound. Because like these are inclusive bounds we have, right? Yeah, they're inclusive. Yeah. So what is the number we actually want? So we want so what do we want? We want x plus whatever the num is has to be bigger or equal to lower, right? So that means yeah, how do we rearrange this? I think we just do lower minus x. Yeah, so lower minus x will get us the actual correct left bound that we can use. And then for bisect right, so for the right hand side, well, upper has to be greater or equal to x plus whatever num we get. So that means we just minus x here. Wait, but that means the number has to be, well, yeah, if we swap this around, it will be number is smaller than that, right? Yeah, actually then the bound would work, I think. Yeah, that should work. So just upper minus x. Wait, but that's slightly weird then. Wait, I need to think about this a tiny bit harder. So we have x plus nums has to be greater or equal than lower bound. So that means nums has to be greater or equal than a lower minus x. Oh, okay. So when we get the left index, so like when we get the left index, it's going to have like a bunch of elements there, and then we have like the right index. So yeah, when we do minus, it will just get rid of all the elements that are like smaller, I think. So yeah, and then we just want this range here. So yeah, actually that'll work. And we just want so number of pairs we set at 0 at the beginning, and then I think we just want to add r minus l, because so for example for this list here, if you're looking at 0, the right bound is going to be here because it's bisect right, and then left is going to be here, so it's going to be 3 minus 0, and yeah, there will be like 3 elements in there, so it should work. We don't have any off by 1 errors, I hope. So yeah, does seem like it works. But does it though? It does, and we got our 100-day streak. So yeah, this question, I think like as long as you know sorted list, it's pretty it's not too hard to figure it out, I guess. Yeah, but if you yeah yeah, I'm not sure how you would do it without sorted list, cause like you need to remove elements in log n time here. But yeah, well, thankfully we have sorted list here. But yeah, thanks for watching, and I'll see you tomorrow. Bye.